Hello all, so let's solve a bit of a hard problem. So let me reset what I did, and also I'll try to explain it step by step. I have gone through the solution of this problem, but it's a bit tricky, and so I came up with a solution by going through a lot of problems, similar problems, and this will be the most easy to understand, and the time and space complexity will be both O of n, O of n, that we will see. Okay, it will be O of n and O of n. I'm writing it in advance. Okay, but let's continue with the brute force. Okay, that what's the question says first. So the question says, oops, let me just drag it. Oops, why? Okay, so we are given a string and we have to calculate first all possible substrings and then calculate all unique characters of the substrings. Okay, and sum it up. So here for ABC, we know that all possible substrings are ABC, then AB, BC, and ABC. So here unique is 1, 1, and 1. Here 2 unique characters, and then here 3 unique characters. So at the end, we have to sum up all the unique, and we are getting that. But the trick is, or the point to note is that if we are considering this substring ABA, okay, then we have to just consider one uniqueness. Okay, just B is unique. A is not unique here because A is repeating. Okay, so that is what we have to consider or take care, and that's what we have to return. So similarly, here they have written here as well that for this string Leetcode, only 5 unique characters are there, which are L, T, C, O, and D. Okay, because we are not considering E because E is repeating thrice here, and that's why it's not considered in the unique character. Okay, so really simple. Let's start with the brute force. Okay, so brute force will be to find all the possible substrings. Okay, so let's find that it will be A, B, then A, all single, single, and one more thing. If you read the problem statement, notice that substrings, some substrings can be repeated, and in this case, you have to count the repeated ones too, and that's why I'm writing this A here again. Okay, so now for two pairs, either it should be AB and BA, and for 3 it's just one ABA. So you can see at the end we are getting 1, 2, this is one uniqueness, one unique character. Here it has 2 unique characters, here it has 2 unique characters, and here it has just one unique character. So if you sum up 1, 1, this is 1, okay. So 1, 1, and 1, which is 3, plus 2, 5, plus 2, 7, plus 1, 8. So in total, we are getting 8. And that's what our answer is for ABA string. So what we can do, brute force is this. Let's rough it because we need some space. I'll try to explain it everything here only. So what we can do, can we do something else rather than brute force? Because brute force will take O of n square. We have to calculate each of the possible substrings. So there will be a nested iteration, right? And that's what we can avoid somehow. And the trick is to think opposite way. What I mean by opposite, so the straightforward way is, as I said in the brute force, that first calculate all the possible substrings and then calculate in each substring the unique character. But what we can do the other way around, like for each character, let's say we are considering the character A, for each character find all the substrings that consider or that consist of A as unique character, and here it will be A and AB, right? So we can do the same thing but the other way around, and that's why I have written other way around. So it's like first for each character find the substrings, or this first is not needed. So what's the approach is, for each character find the substrings that contains that character uniquely. Okay, just unique way, in a unique way. Okay, so this is how we can do, correct? So we will get A and AB. Okay, similarly we know that, let me write that which I rough, A, ABBA and it was ABA, right? So here we have 2, here we have 2, here we have just 1, and here also 1, 1 and 1. Okay, just so for this A, we already calculated A and AB. So let's cross it here that A is done and this AB, just 1 is done, 1 is still left. Now let's go to B. Okay, so how many substrings are there for this B, which it contains B as unique? It will be AB, firstly the B alone, then AB, then BA, and then ABA. So there are 4, right? So let's cross them. B alone, then now AB is gone, then BA1 is gone, 1 will still remain, and ABA is gone. Okay, and now let's consider the last A. So how many substrings will be there for this last A that contains this last A uniquely? So it will be just BA and A again. So this A again and this BA. So you can see everything is gone, and in total we have done this. Okay, so we'll get 8. We've done this 8 times, this crisscross. So we'll get 8 as our answer. So we have to do something like this. And how we can do that? So I have already shown how we can do that, but let's see in a systematic way that can be understood. So, and we will fill up this table. Okay, that's why I have drawn this table. So again, we'll go through ABA, and let's focus on this A, first one. So how we will calculate how many possible substrings are there? We know there are 2, A and AB, but how we will get that number 2 mathematically? So we will use parentheses. Okay, so it's not like we are actually using parentheses, just to show you that how many substrings will be there. So on the left, we can just put, because we are on the border, right? So we can just put 1 parenthesis, right, on the left. So left will be just 1 parenthesis. And on the right, we can put here and here. We can't go beyond this, because if we go beyond, then there is again A, and we can't consider that because then it won't be unique anymore. A is not unique. So only right side, we have 2 possibilities of putting the parenthesis. So total will always be left into right. Okay, so in total we are getting 1 into 2 is 2, and we know which these 2 strings are. This is the count. Okay, total count. This is not like some total count of how many substrings will be there. So total substrings count, let's write that, substrings count. So it will be A and AB, we know that. So let's write that for I at 0, so at the 0th index A, whatever character is at the 0th index, this A, what we are doing, we are calculating left as 1, my right is 2, and we are getting total as left into right, which is 2. And what are those 2 strings? Those are A and AB. Okay, I'm just writing those 2 strings. Now let's go ahead and consider for B, or let's consider A again. Let's finish all the A's. Okay, so for this A, what we can do, on the left we can write parentheses here and here. So left we are getting 2. Okay, so now I'm considering the other case. Left we are getting 2, and on the right just 1 possibility because it's the edge. So again, multiplication will be 2 into 1 is 2, and this times the strings will be, let's write them, will be B, A, and just A. Okay, so let's write that in the table, that now I'm considering the last index, which is 2. Okay, I equals to 2 index. A, left we are getting this time other way around 2, right we are getting 1. So total is 2, and the 2 strings are BA and A. Okay, let's move ahead and calculate the last one, and let's remove this time. Okay, so this time we need to do for B. So for this B, we know that on the left we have 1 and 2 possibilities. On the right again we have 2 possibilities. So total we have 2 into 2, which is 4. And we know which those 4 strings are. Let's write them. So firstly, it should be AB, starting from the left, okay? Then B alone, then going to right, which is BA. And at the end, we have the entire string, which has B as unique, ABA. So total we have 4, correct? And that's how we get 4. That's how we have the combination of parentheses, that for each parenthesis, how many combinations are possible. For each left, how many possible combinations with right. Okay, all the possible places. And that's why we have to multiply. So let's write for the B. Okay, you can do B first as well. It doesn't matter, but I just did it. So left is 2, my right is 2, and total is our 2 into 2 is 4. And we know AB, B, BA, and ABA, the final entire substring. So if you count this, 2 plus 2 plus 4, we'll get total as 8. So every time we have to increment our count, and we are getting 8. So we have to do something like this. And for this, we know that firstly, from this, we can conclude that we need to know all the indices of any particular character if it occur more than once. Okay, so something like hash map can work. So for example, for this substring, we have to make a hash map that contains all the indices. So A occurs at 0th index and 2nd index, and B occurs just as 1st index. Okay, so we have to make something like this. So let's begin with that. Okay, and let's write our hash map first. Let's populate. So our hash map will be, we will use default dictionary module because we need our keys, sorry, our values as list, and that's what this default dict will provide. So now in our hash map, what we can say is all my values are list, and that's what we need. Let's populate. So for I in range, length of S, we have to traverse. What we have to do, hash map of, or key should be each unique character, that is S of I, dot append. And what we have to append, each index. Okay, let's print this. I'll show you that what I mean. See, of course it will be a wrong answer, but let's see our case, ABA. See, A is at 0th and 2nd index and B is at 1st index, and that's what we have seen already. But now it's time for calculating those left and right, and we know that what we have to do, we have to go through the each and every character, it's each and every occurrence. Like we also followed, like we first finished A, okay, then we meant to B, right? So let's follow the same process, that let's go through the 0th index or the occurrence of A, the first occurrence of A. So for that, what we have to do, we have to traverse through our map. So this will be the key in our map. So let's write first for loop, and for, so now we are inside this, okay, our character is A for first iteration of this for loop. Now we have to go through all of it occurrence. So now we have to go through the entire list. Okay, so firstly I will get that list. Okay, so for J, let's write J here because it will confuse with those that I. Okay, so for J in range, length of, so we have to traverse through entire length of this. Okay, so firstly we have to get this, and how we will get this, we know that we can get this from the index dictionary of that character A. So if I write this, I'll get the values. I'm going through its length, so I'm going through the entire length of this. Okay, so in particular for the first iteration, if I have to show, I'm going through this entirely. So we are finishing up with A. And why I have written this J and I differently, you can use I here, doesn't matter, but it will confuse. So I is the index of each element of the string. So this is 0th index, 1st index, and 2nd index. Whereas J is this 0th index and the 1st index. So here 1st index is 2, And we know that this 2 is the ith, which is this one. I hope this is clear. This is not that much important, but just for avoiding this confusion, I have written j here. Now we have to calculate left and right. Now if you might wonder that this is a nested iteration, it's not O of n that I mentioned, but it is O of n. Firstly, what we are doing, this will take O of n, of course, plus this will also take O of n. Why? And O of n, O of 2n, and we know that in big O, 2 doesn't matter, right? So it's at the end, it's O of n. So firstly, if you are struggling with this, that this is a nested iteration, it's not, because we are going through 0th index and 2nd index. So we are done with 0th and 2nd, and then we are going to 1st index, which is this one. So at the end, we are traversing the entire string once. So this is also O of n, and this is also O of n. So at the end, it's O of 2n, but we know that constant doesn't matter in our big O. So this is O of n, okay, just to let you know. And for space as well, it's O of n, because we are storing in the hash map. So let's see how we calculate left and right. And also we need one variable, which is our answer. Let's call it, we have to sum, so let's call it sum. Okay, m, okay, because sum is a keyword, so we need double m. And of course, for every left and right, we have to increment that sum by which value? By multiplying those left and right that we get. And at the end, we have to return sum. Perfect. Now the trick is to write left and right. Okay, so pay attention. This is important thing. Again, I'll consider this same iteration, that firstly we are inside the first for loop, we will be inside here, and then inside the second for loop, we will be at the first index here, or we can say the 0th index, which is 0, and first index, which is 2. But let's continue step by step, that which we are here, and we know that this 0 corresponds to this index of this a, because we are first considering this a only, 0th index a. So we know that on the left of it, we can just put one parenthesis, right? So how we'll calculate left? If I'll just simply take the value of this index, then we won't get the correct answer, because we know that the value is 0 at that index. So firstly, let's take the value, which will be j. Okay, but we know that this will be 0 and we need 1. So we need to handle it like this, that we need plus 1, because on the left we will need 1. We need 1, right? Because for this a, we know that our left value, you can always refer the table, that for this a, our left value is 1. So we need 1, and we know that from our index we are not getting 1, we are getting 0. So we add 1. Just going through for this particular case, we will improve it, but we will see soon that this is an edge case. Okay, and we will, if I'll introduce it now, it will be confusing. So let's go step by step. And for right, we know that we need to, for this a, we need to have 2 braces. We know this, right? I'll show you again that it will be here and here, correct? So we need right as 2. We know this. And how we'll get 2? So simply what we can do to get right, we can again use our hash map. Let's copy from here value, but it will be, what we have to do, we have to take j plus 1 index. Okay, so that is, j is this one. Okay, don't confuse it with I. That's why I've written I and j differently. So this 2 is the ith index, which is this one. Okay, but here we are just focusing right now on here only. So let's focus on the 0th index only. Let's not go with this 2. So we are focusing on the first character right now. We are on the first iteration of the loop. So how we calculate the left? For right, we again have only this. Okay, but can we make use of this? We know that the next, we can't go beyond next occurrence. Okay, but we can go until here, just before this a, for this particular a, to place the braces. So we have 2 places where we can place. So we can use this j plus 1, the next occurrence, which is at second index. minus what we can take, the current occurrence, right? So we are at the 0th iteration, okay? So we are at here. So what this will give is 0 plus 1 will be 1. So it will give first index, which is 2. Okay. So this is giving us 2, sorry, minus this is already, we know, 0. So we are getting 2, and we know we need 2, right? For right is 2. So in total, what we will do, we'll update our sum as 2. So sum will be updated, and we get to the next iteration, which is this one now. Now our j is 1. Okay, so j is the index here. Okay, don't confuse that. I'm repeating that. Now let's calculate the left, and let's see if we are getting the right answer or not. So still we are at this particular a only. Oh, sorry, now we are at this one. Okay, for j equals to 2, because we are considering all the occurrence of a at a time. So now we are at here, and we know that for this, what should be the left? We know on the left we should get 2, and let's see whatever we have written right now will give us 2 or not. Okay, so here this 2 I'm talking about, we know that for this particular a, we need this and this 2 places. So for left it should be 2. So for left it should be 2. Here we won't get 2, because now our j is 1. We are here at this iteration, and this value is 2 that we will get, which is this one. And if we add plus 1, we are getting 3, and we know that we just need 2, right? We just have 2. So this won't work. We have to handle left differently. But then you will say, then what we will do? So this is an edge case. Now I will tell you what's the edge case here means. That whenever any character is occurring the very first time, okay, then we will use this, right? So how we can say that it's occurring the first time? When my j is 0. J is this one, okay? So when we are at the very first index, don't confuse this j as 0 with this 0, okay? So when we are at the first index, okay, this 0 indicates this 0's position of a, but it's not necessary that if we have some character in future in some other string, let's say we have c, which is occurring in the middle somewhere, right? Then this won't be 0th value, okay? But the index is 0, okay? So this jth index, which I am talking about. So I hope this makes sense. So if this j is 0, then this will work. That if it's the first occurrence, then it will work. But as we have seen that when it's it's not the first occurrence, okay? I'm not saying it's the last occurrence, but when it's not the first occurrence, we will see last occurrence. That's also an edge case. We will handle it on the right side, in the right variable. But let's focus first things first. Then what we have to do is that if this is not the first occurrence, and we know that this is not the first occurrence, then we have to handle it differently. So else, so what this means is that if my j is 0, we will use this formula to calculate left. Else is the same as conditional operator in our C and Java that we have. Else what we have to do, we can just write, let me copy paste. What we will do, we will take, right now we are at second position, or j equals to 1, okay? So we can write this minus j minus 1. We already know that we are not at j equals to 0. So this won't give us an error, okay, that minus 1 index doesn't exist or something, right? So what we are simply doing is that we are subtracting this value from this value and then calculating left, okay? So we know that for this particular a, we need left value as 2, okay? We can't go here, so we can go just before this, okay, occurrence of a. So we need left value as 2, and this will give us 2. We can see that because we know that the next occurrence is at 0th index. And the previous occurrence what was at, this occurrence is at second index and the previous occurrence was at 0th index. So we know the difference, that how much we can place parentheses in between, right? So this will work out for that purpose. Now similarly, again we are at here only, okay? We have to calculate the right side of it, and we know that this is at the edge, but I won't tell it at the edge. Let's say this is the last occurrence of A in the string, and if we calculate right with the existing formula that we wrote, it won't work. Why? Because let's see if it won't work or not. So we know that J is 1, right? And we don't have J plus 1th index. We know that J is 1, and here we don't have second index. It's 0th index and first index. We don't have second index. So this will give out of bound error, correct? So we also have to handle this as one of the edge case. And what's that edge case? So this is not the edge case, this is the general way, but the edge case is, so let me just keep this aside for now. So when any of the character is my last occurrence, and when any character will be last occurrence, when we reach the end of this list, okay, this list. I'm not talking, this might be confusing that we are considering this A and this is at the end of the list. No, there might be some other string in future, but it should be the last occurrence. So A is not occurring anymore. There can be C, D, E, F, so on. So it's not at the edge, right edge, I mean. But it's the last occurrence. It's not occurring anymore after this. Okay. So how we can do that? That we are at this place. And for that, what should be the jth value? Jth value should be length of this. Okay. -1, of course. So here the length of this is 2. But my J, which is the last one, is 1, right? Jth first index, 0th index and first index. So we have to write firstly the length of my this, just the character, not any index, and we have to subtract 1 from it. If this is the case, then what we have to do? We have to use differently. And if this is the case, how we can calculate the right? This will be the else part, okay? So let me make it nice and clean. That else, this will always work, okay? But this is the edge case, that when this will occur, we have to write something here, okay? So what we can write? So let's try to calculate for this case, that we are still here, right? And we know that our right side should be 1 for this A. And in order to get it 1, we know that this will give us error. So in order to get 1, what we have to do? We have to simply write, because since it's the last occurrence, we can make use of our entire string length, which is 3, and we will subtract whatever is the, because we know that we are at the last occurrence, right? So whatever is the last occurrence, we can just subtract that. Okay, hash map of character of J. What I mean is that, let me dry run it, that if we are at the last occurrence of any particular character, then we can make use of length of S, which is 3 in this case, minus the value here, which is 2. Okay, so then we know that, and this will give 1, 3 minus 2, 1. And we know that for this A on the right side, we just have one place for the parenthesis, right? So, and we know that this is, we are at the edge by this condition, that my length of this is 2, minus 1 is 1. And we know that when we are at the 1th position, J 1th index, first index for this J, this is a bit confusing in terms of indexing. But this is how I can explain you in the best way. And at the end, we have to return the sum every time. So let's see if we have done any mistakes in this regards. Should be some. Okay, nice. There isn't any. You can see we are getting it nicely. And the space and time complexity, as I said, both will be O of n, O of n. Let's analyze. using Leetcode. See, OFN, as I explained why it's OFN, and memory also OFN because we are using this hash map to store. So we are using this extra space. So I hope things are clear. There is a similar problem, okay, which is this one, total appeal of a string. This is also a hard problem, but the intuition remains the same. Okay, so just try to attempt that, and we will do that in our subsequent video. Okay, so stay tuned, keep learning, and see you soon.